Hello everybody, welcome to another lesson. This lesson is a continuation from right where we left off in our last class. So we had this problem, we used the cosine law to solve for one of the sides over here, and we're looking for the other sides. So I've got a little extra information in here. I put the side that we found here just for visual reference, and now we can see that from this point onward we can actually use the sine law to solve for this missing side, because we have this opposites situation, or you can call it yeah, we have like a pair of side and angle. So we're going to use the sine law. The reason we use the sine law instead of cosine law again is just because it's faster. You could use the cosine law if you want, but the sine law is faster. So I've said use the sine law, it's faster. So that'll be our second step. How do we use it? Well, we need to set up our rule first. So we have a side over the sine of an angle. And notice the side I've started with, the side and its relative angle are because of the pair I have earlier. And then I need to think, which side am I looking for? Well, I'm either looking for the angle A or the angle B. And it turns out it doesn't make any difference. As soon as you have this pair, you can use it to solve for either of these. It makes no difference whatsoever. And so I'm just going to go ahead and choose A because it's the first letter in the alphabet. And just to double check here, we have C, we have angle C, we're looking for angle A, and we have side A. So let's set up our numbers into this. And now I'm going to do a little cross multiplication. What I'm going to do, in order to get sine, I need sine of A, or I need A specifically. In order to get it on top, I'm going to do some cross multiplication. I'm going to multiply it by this side. It's going to go over to that side. And this side is going to get multiplied by that side. And you'll see things start to come together here. So you have 73. Well, I'm going to move the sign over. And in fact, I'm going to take this 73 and move it over there as well. So just see if you can follow this move. The sine A has been moved over to the left. 45 stays where it is. Sine 80 joins it. And now it's divided by 73.94. So really, if you find that a little bit confusing, let me try to make it more clear. The cross multiply, how it works is we can kind of move things around. So we can move, the sine will go along this diagonal to this side. The 73.94 will go along the diagonal to that side. And then we want the sine alone, so we need to also move the sine 80 over. So you can see, now we have 45 sine 80 on top, 73.94 on bottom. But of course, that's hard for you to write on paper. I just have the opportunity to have this kind of digital notepad. So I'm going to move things back to where they started. And if you want a reminder of how to do that, you can just watch that section again. So I need angle A. It's just the sine inverse of this expression here. 45 sine 80 over 73.94. My child is freaking out today. And then you could write this as a decimal inside before you evaluate it, or you can put it all in your calculator at once. Either way, you should get something that looks a lot like this. 36.84. Sorry, I've got a little something caught in my throat today. So I'm going to go back in my table at the top and just write in 36.82. Just in case you want to see at the end that we've solved for everything. And now that I've found that A, so I'm just zooming out so we can see everything. Now that we've found that A, our third step, the smartest method, would just be to use the angle sum principle. And that would be really smart because the way that I'm looking at this now, by the time I've made it to this point in the problem, I have two angles. And it's always best to use those two angles together to solve for the missing angle. That would be the fastest way. We could do sine law again. We could actually do cosine law again if we wanted to. We can always use cosine law most of the time. But let's just save ourselves the grief and do it this way. That is our answer B. So I'm going to write in here 63.18. So when we finish this, what we'll see is that we've used the cosine law, we've used the sine law, and we've used the angle sum principle. Those are really the only three methods we can use to solve these triangles. There is nothing else to do. There are no other ways to solve these triangles that we've ever learned. And that's actually a good thing. It means that there's not a whole lot to this unit. Now, 3. I just want to be clear. There was another way we could have done 3. You could have done 3 through sine law, if you want. Or you could even have used cosine law. But I'll leave that to you as an exercise if you want to try it out. I guess what I'm trying to say is I've used the shortest possible path to get to the answer I'm looking for. But if you really get stuck, just try your laws, see if things work, see what you're missing, what you're given, and you can usually puzzle this stuff out once you get a little bit more practice with it. So speaking of more practice, let's try number 3 here. My goodness, I can't get this out of my throat. 1 second. Okay, I just paused to take a drink of water. If I keep coughing, I'm really sorry. Let's just draw a diagram for this. Doesn't need to be anything fancy, just, little diagram. And we can label it whatever way you want. I'll just put A, B, and C over here. Now we know that 65 is angle A, we know that side A is 20, and we know that side B is 15. If you wanted to write that as, in our kind of table form, that's perfectly fine too. In fact, that would be the smarter way to do it. Having both would be the best. And now we see extremely easily and visually that we have a pair. We have this pair of opposites, a side and an angle opposite. That's because we have a side-side angle triangle. We have 2 sides and then an angle opposite one of those sides, which means I can use which law? Do you remember? If we have side-side angle, it means we're going to use the law of sines, because this opposite situation always is law of sines. And now we just go about our business. We're just going to set up our law of sines. I have the most information about A, so that's where I start. And then I can just go ahead and choose which piece of information I want to solve for. In fact, we don't have a whole lot of choice here, because we don't have anything about C. So we're going to start by taking the piece of information here, B. We know that we have side B, and we can go ahead and solve for angle B. Okay, so remember, when we're looking at the law of sines, we just piece together what to do based on what we've been given. So let me just write out the law of sines again for you. So it's important to notice that we have both of these pieces. So it truly is up to you, in a lot of cases, where to go next. We have B, so the obvious option should be to solve for angle B. That would be the obvious option. Unfortunately, we don't have C and we don't have angle C right now, so we don't even have an option. But if you write down the law of sines, you should be able to puzzle out what it is you're looking for. And in this case, we're looking for sine B. So let me do a little trick here. Maybe it'll make your lives easier. We can do the reciprocal of the sine law, and sometimes that makes our lives easier. So this is no different than what we started with, but it makes our lives a little bit easier because we're solving for this B here. So let me start putting my numbers in. Okay, we've got 15. Some students like to work out what that left side is equal to, so I'll do sine 65 divided by 20. That would be 0.0453 on the left, and on the right side we have sine B over 15. So I'm just going to multiply both sides by 15. That'll cancel, and then I'll end up with sine B. So let's make some room here. I know you can't necessarily do this, but for the sake of clear notes. So I'm looking for sine B. Sine B is that piece here. We just need to work out 15 times that. So 15 times that is 0.6797 and a few decimals, which if we get the inverse sign, it'll give us B. Do the inverse sign of that, it's 42.82 degrees. I'm going to put that in my table before I forget about it. Okay, so I've used the law of sine to find that angle, And now the next thing I should do, well, once again, I have two angles, correct? I've got two angles now. I can just go ahead and solve for our missing angle. That would be the easiest course of action to take next. So once again, A plus C, all the sides of a triangle are equal to 180. Sorry, all the angles in a triangle are equal to 180. So take 65 and 42.82 away from 180, you get 72.18. And just like that, we've got another piece of information. Maybe you can see where this is going. We have tons and tons and tons of options now. We could use A again with sine law. We could use B with the sine law. We could even use the cosine law if you wanted to, but there's no reason to get that complicated. I'm going to choose to use the sine law again, and I'm going to choose to use A again. And the reason for that is because A, all the information about A was given in the question. So I know that the numbers are correct. If I went ahead and used my B in the sine law, it wouldn't be wrong. I have all the information about B, but if I calculated B wrong, then my answer would be wrong. So it's better to be safe than sorry, as they say. So let's see, what do I have? I have A, I have little angle A. I'm looking for side C, and I have angle C. So this one is going to be a little easier to calculate. Just going to rearrange here. C equals, and again you can do cross multiply. All I need to do is cross multiply the A and the sine C to cancel it out. So A times sine C, A is 20. Oops. A is 20. Sine C, C currently is 72.18 divided by sine of A. A is 65. And then if you work all that out, if you just calculate those pieces, you should get something close within a few decimals to 21.01. That is C. Okay, not degrees. That's a side. My bad. Okay, 21.01 is the side. 21.01 is C. Now, again, there's many ways to do this. I chose to do the sine law first, which is definitely the most appropriate method. You could, at some point, use another sine law in this. You could have used a cosine law, but I did the shortest and most efficient method for you. So, you can start this question again, leave it blank, start it just from the top, write it down on your own and see if you can get the same numbers as me, but maybe try a different method. There are many, many, many equivalent methods. I'm just going to show the one. So, question 4. Question 4 is a little bit of a tricky one. I'm going to put a little star by it. It says, find the largest angle given the three sides. So find the largest angle in this triangle given three sides. So it says we're given the three sides right away. I don't even need to read the rest of the question to know that I've been given three sides, which means I'm going to use law of cosines, or in other words, the cosine law. That's before I do anything else. I know that three sides is automatically the cosine law, so you get that for free. But let's write out A, B, and C, and sides A, B, and C, just to make it crystal clear what we've been given. We've been given the sides here. All right, that's A, B, and C. We don't have any information about the angles, so we're kind of out of luck on that one. But let's take a look. We have been given A, which is the largest side, and that will give us the largest angle. So let me make that clear to you. The largest side corresponds to the largest angle. That's super important to know. You might be wondering, okay, why are we looking for this largest angle? How do we approach it? Well, let me finish my thought and then I'll show you what I mean by this little star up here. So let's just say we had a triangle that looks like this, okay? In this angle, in this triangle I should say, it should be fairly clear that this is the largest side, largest angle, and therefore its related side is going to be the largest side. So when I say that the largest angle is related to the largest side, that's what I mean. You can look at this triangle and say, okay, that's definitely the largest angle, and it must relate to the largest side. So when I did this little operation here, that's how I knew. Now, I said I was going to relate back to this star. So this star over here, I'm going to tell you, give you a little piece of advice. And what that is, I'm going to say, see the note on page 2 about 3 sides. Page 2, let's go looking. Note on page 2, note on page 2. Note, this note. What does it say? When you're given 3 sides, start by finding the largest angle first. That way the other 2 angles will be acute and the law of sines will give the correct answer. So this is saying that if we need to find the largest angle first, if you are given 3 sides, you should find the largest angle first. Everything will continue from there. All right. In this question, we're only asked for the largest angle, but in future, we might be asked to solve the whole triangle. So the first step is going to be to find the largest side. In fact, this question is only one big step. So let's go ahead and write out the law, cosine law. Okay. So once again, the law of cosines. And I have everything to do with A. So this is how I'm going to write it. We know that we have A, and we're looking for A, angle A. So I'm going to piece it together. I know it's cosine of A. I know it's A squared equals that. And then our related sides, right? We have this interior angle or included angle. So the rest is B squared and C squared, just like Pythagoras, minus 2BC times cosine of A. So I've pieced together how I need to use the law of cosines. Now I just need to put all my numbers in. And you should see that A is given, B, C, B and C. And all I really need to find is A. So I'm going to go ahead and write out all of my given information here, and hopefully you can see what's going on here. You should write out this step on your own, just to make sure that everything makes sense. Alright, so I've just replaced all of my letters with all the information that I know. And now the rest is going to be me calculating and solving. So I won't explain this, I'll just write it down. So we can see this is that. All of this is that. And all of this is this. Once again, I'm slowly getting closer and closer and closer to my cosine. I'm going to bring this over and subtract it, and then I'm going to divide by the number next to it, okay? So it's going to look like this. My angle A is going to be a cosine inverse of 154.2519. That's these two subtracted, divided by negative 1839.8754. And that comes from this piece here. So if you did it out fully, you'd see that. This negative must be included. Okay, let me make a note of that because it is extremely important. I'll make it in purple, why not? So the negative must be included, or you will get the wrong answer. And that's because of the way that cosine evaluates things. It'll think it's in the wrong quadrant, it's all just going to go wrong. So just make sure that if you see your negatives in there, don't ignore any of them, they're all important. And this should give you 94.81 degrees, which is the answer I was looking for, or at least the piece of information I was looking for. So long story short, this gave us 3 sides. If we're given 3 sides, use cosine or the cosine law to find the largest angle. That's the first thing you do, and then if you need to do more after, well, that's where you start. So hopefully that's fairly clear. I'm going to change my mind on this purple, change it to more of a red color just because I'm picky. And again, if you have questions about this, make a note of the page and the question and just send it to me, and I'll happily go through it with you whenever you're free. So these questions, 5 and 6, are more questions similar to what we've done already. So I'm going to say, try question 5 and 6 yourself. Okay, so this one is for you to try. I'm going to go ahead and go to the next one. Oops. This is also for you to try. But I'll give you a little hint, okay? I will give you the full solutions before the end of this video. But I'll give you a little hint of how to start it, okay? which you should really genuinely try to do this yourself. All right, so in this question we were given 3 parts. We're given side, side, side. We know that that's cosine law, and if you're given 3 sides, you should start by finding the largest angle. So that's what we're going to do. I'm going to put up what the answers are, and then I'll put the full solution there, and you can compare your work. But first thing you should do is pause the video and try it yourself. So I just popped up the answers there to the side. That's where you should be that's what you should be comparing your work to, assuming that you've tried it yourself. And now I'm going to just write out my full solution for this, and hopefully it'll make some sense to you. Here it is. So take some time to pick through that. Notice at the very first step, this number 1, first step I used the law of cosines, solve for the missing angle B. Once I have the missing angle, then I can use that with my sine law, because I have its related side, B, and solve for any other piece. Because I've been given A, I can solve for angle A. Once I have that angle, I can use the angle sum principle. So hopefully you can pick through those solutions and make some sense of it. Again, if you can't make sense of it, let me know. I'm happy to go through it with you one-on-one. Now for question 6, same sort of thing. I'm going to have you try it yourself. I'll put the answers here first, just so that you can have a chance to pause the video and try it yourself. Okay, there's the answers. That's what you should get if you solve this question yourself. Those are just the missing pieces. And now I'm going to give you a hint for those of you who want to know where to start with this. So my hint is find angle A, then use the law of sines, just like question 1. So if you relate this question to question 1, you'll see what I mean. Let me just write out the givens, just to give you a little push in the right direction. All right, this is our givens. And notice we have a very conspicuous missing space here. We can use both of these angles to solve for this angle. That would be the first step I would use. And then you would be able to use your sine law because you'd have a pair. So hopefully you're starting to see patterns with this sort of thing. I'm going to write out the solution now, or at least paste the solution, and you can compare it to your own work. And you really, really should try this yourself. And here you go. So what I ended up doing is I found that angle A was 99.4 degrees. From that, I decided to use the sine law, because now I had all the information about A, and I found side B, which is 55.08, and then I went ahead and found side C. But what you'll hopefully notice is that in both cases, I'm using my information about A, because that's what I first started with. That's my easiest and most trustworthy piece of information. I'm using that to solve for the pieces that I don't know. I could have done them in either order, I guess is my point. Steps 2 and 3 are both sort of equal. And you can approach either one in any order. Hopefully I've made myself clear with that. All right, so that's it for this section of practice problems. Let's take a look and see what the next few problems are going to have for us. So use the sine law and the cosine law to solve applied problems. So in one way we can say that these are just our word problems again. But thankfully most of the time these questions are actually a little bit easier than in other units because we know we're still dealing with these oblique triangles. So let's see if we can make sense of a few of these here. Starting with question 1 now. A fire tower at point A is 30 kilometers north of a fire tower at point B. So you can tackle this in whatever order you want. I like to try drawing it first. So I have something north. Point A is north from the fire tower at point B. And I know it's 30 kilometers. That distance is 30 kilometers. It says a fire at point F is observed from both towers. So we know that this is a triangle, right? So we have a point F, which is the fire. Point A can see it. Point B can see it. So we don't know anything about any other information yet, at least as far as I've read. So if angle FAB is 54, so really it's trying to tell us that angle A is 54 degrees. And if angle B is 31, is really the way that this is being told to us. find AF, or in other words, find this side here. Okay? In my books, that's really asking what's side B? You know, what is side B here? Okay? So let's write out our givens and our unknowns again. We've been given angle A. We've been given angle B. We've been given I guess I don't have C, do I? It should really be F. That's our fire. So our lowercase f is the side that I've been given, 30. And you'll notice, hopefully, that we don't have an included angle. So this type of triangle we would call an angle-angle side. And with angle-angle side, well, we're going to use eventually the sine law, but the first thing I would notice is that I've been given two of the angles. I'm going to solve for the third angle. So that's going to be my first step here. If you solve that, you end up getting f equals 95 degrees. 95 degrees. From that, once again, something I've talked about a lot, you now have a pair. And if you have this pair of opposites, you can go ahead and use the sine law to solve for every other piece of information here. So it's only asking for a f. So let's be very clear, we're looking for side B. That's the question that we're looking for. That's the side we're looking for, okay? So our pair, our helpful pair, is going to be f. So let's just say sine b over sine b is equal to f over sine f. Because once again, I've got f and its related pair 30. I've been given 31, and I want to go ahead and solve for our missing piece. So that's why I set the sine law up the way that you see it here. Let's just put in our known information. We just need to get rid of the sine 31 by bringing it to the other side and calculate it. If you calculate that out, you should get 15.51. And it's kilometers. The question gave us units in kilometers, so it's a good idea to keep that in there. But at the end of the day, our answer is 15.51 kilometers. So the distance from the fire tower at point A to the fire is 15.51 kilometers. So most of this question was not all that difficult. It's things we've seen before. Really, the only trick was figuring out how to set it up, and that's often going to be the case. Let's do one more, and that'll be enough for today's video. So a bicycle race follows a triangular course. The three legs of the race are, in order, 2.3 kilometers, 5.9 kilometers, and 6.2 kilometers. So I'm just going to go ahead and draw just a triangle. This is my 2.3, 5.9, and then I'm going to draw a long line for 6.2. And it doesn't need to be to scale. This is just my approach. 2.3 kilometers. My next one in order was 5.9, and my next one in order was 6.2. So the way that I would probably explain this, or that I should explain this, is we are going to start here, and you're going to go this way, then this way, then this way. That's how this has been explained to me. And just to keep things organized, let's just say that your starting point is A, your midpoint here or first stop is B, and then C in that order. And now we have a fully labeled triangle, and if you are very careful, you're paying attention to everything else, you should see that if you've got three legs of the race and three sides, we have a side, 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 which means we're going to use which law? Do you remember? Now give yourself a win here. Side, side, side is the law of cosines. All right, so let me write out all of our given information just to keep it in a table form again. So I almost trapped myself there. I was reading the question off from the question. I was reading the numbers off the question, but I wasn't paying attention to my actual triangle. So angle A is related to side A. So side A is actually 5.9. I almost tripped up there. That was really close. B, 6.2. C, 2.3. So make sure that you take the time to pause the video if you need to spend some time thinking about this. The only thing you're going to do is improve your own understanding. if you take that break. So sometimes it's good to take a little break. Now, what is the question? We're not going to fully solve this triangle. That'll be a waste of time. So let's see what the question is. Find the angle between the starting leg and the finishing leg to the nearest degree. This is the starting leg, and this is the finishing leg. And so I'm looking for this angle, A. So A is what? Is really my question. That's pretty easy. Now I just need to solve my, put down my law of cosines, which involves A. So once again, A starts it, A finishes it, and you can fill in everything else. The other legs are what's on the other side, B squared, C squared, minus 2, BC, cosine of that angle A. Let's put all of our numbers in and solve for that angle again. We've done this numerous times now. Hopefully you're getting a little bit better at it. But if not, you can just watch me do my work now. Again, just missing our angle A here. I'm going to multiply out. Once again, this is related to this. This stuff is all related to this. And this stuff is all related to this. Oops. Yeah, okay. And I'm going to do my regular rearrangement and dividing now. Okay, so I changed my mind a few times while I was doing that, but the basic idea is there. Just a few things to point out. This negative divided by a negative divided by a negative, comes out positive, which is why I changed these to positive. It's important that you keep track of those negatives. But in the end of the day, you might have a different strategy than me, but you should be getting basically the same thing. So let me just put this back up on the page so that I'm not kind of cramping too much. That's good enough. And let's see. Did we answer the question? A bicycle race follows a triangular course, 3 legs of the race. Okay, find the angle between the starting leg and the finishing leg. That's angle A. It looks like I answered it. If we wanted to fully solve the triangle, we would need to go ahead and solve for side B and side C, and you would likely want to do sine law for that, because at this point we have this, and we can go ahead and solve for any other piece by that. But we weren't asked for it, and so we won't solve. As simple as that. Just answer the question as it's posed, and don't do any extra work. All right. So the next section are more word problems. We have question 3, we have question 4. After that, there's practice. These will be more likely things that you would do on your own, or maybe I'll go through them depending on how things shake out. And then there's another section, extra practice, which is over and above. A little bit on cosine law, not word problem. Another one that's kind of a word problem, but really just a standard problem. And then more practice with just your sine and cosine laws. And then finally, a 5th question, which is a word problem, a full word problem. And then 6 is also a word problem. And then, after page 14, we're done. Okay? So there's not a whole lot to this unit. I expect we'll probably finish it in another video or another class or so. But in the meantime, make sure you understand these concepts. And if you understand it now, then you'll have a really, really good chance of doing great on the assignment and on the subsequent test, whenever that is. Thanks for watching. Have a great day, and I will see you next time.